Hey guys, tonight we're hopping aboard a sleepy spacecraft or two for a long, quiet drift through some of the most unintentionally poetic machines humanity has ever made. The Voyager probes. You're going to ride along with them, past planets beyond sunlight, into space so empty it practically echoes. You might not believe this, but both Voyager 1 and 2, launched back in 1977, are still talking to us. Faintly, lovingly, from over 12 billion miles away. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Also, drop your location and local time in the comments. I love seeing who else is drifting out into the cosmos with me tonight. Now dim, the lights maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You start your night at Cape Canaveral, 1977. The Voyager 2 rocket lifts first. Oddly enough, though it's named 2, it actually launched before 1. NASA always keeping us on our toes. The rocket rises slowly, a trail of fire licking the morning sky, carrying something that doesn't seem all that impressive at first glance. It's beige. It's boxy. It kind of looks like the electronics aisle at a 1970s department store mated with a radar dish. But inside this clunky contraption is the makings of legend. You imagine yourself tucked inside, floating gently among the instruments already far above Earth. The rocket stages fall away. The solar system stretches ahead. You've just been launched into forever. Mainstream fact: Voyager 1 and 2 were part of NASA's grand tour of the outer planets, made possible by a rare planetary alignment that happens only once every 176 years. Jupiter, Saturn, Uranus, and Neptune all lined up just right like celestial bowling pins. You coast quietly toward that lineup. Voyager 1, taking the quicker path toward Jupiter and Saturn, while Voyager 2 goes the long way round, planning to hit all 4 giants. And here's the thing. At launch, nobody thought they'd last more than 5 years. Maybe 10 if they were lucky. Engineers built them to survive the harshness of deep space, sure, but not to thrive in it. No one expected them to still be whispering back at us 40-plus years later. You peer down at Earth shrinking behind you, cloudy blue busy. The chatter of mission control fades. The hum of interplanetary space begins, and already the probes are doing their job. Instruments come online. Imaging systems blink to life. Plasma detectors, magnetometers, cosmic ray sensors. All those gloriously nerdy tools start sipping data and storing it like treasure. A quirky tidbit. The data is stored on an 8-track tape recorder. Yep. The kind your uncle still keeps in a dusty box in his garage. Space history lovingly archived on a medium most cars haven't used since bell-bottoms were in style. Scientists still argue whether the Voyager's success is a miracle of engineering or just staggeringly good luck. The power systems still trickling energy after all this time. The antennas still aligned. The software occasionally rewritten mid-mission using a computer from the era of disco. And as you coast farther out past the moon, past Mars, you start to feel the shift. The gravity of the planets begins pulling you in, like old friends waving from across the street. Voyager 1 horizon adjusts its course. So does Voyager 2. The flybys are coming. But first, there's just this open space. A billion miles of silence. And you gently orbiting a 1970s dream machine. You glance back at the Earth one last time. It's already barely a dot. A pale one, if you will. But that metaphor comes later. Right now, You simply drift. The mission has just begun, and somehow, without realizing it, you've become part of it. A quiet passenger on a long, long journey. You drift now through a space that's starting to feel properly large, where planets are no longer daily headlines and signals take minutes just to arrive. Yet Voyager presses on, and you with it, a silent stowaway, aboard what might be the most charmingly outdated tech to ever leave Earth's gravity. And now you have time to explore the instruments on board. You float past the plasma spectrometer, which sounds more dramatic than it looks. It's basically a very polite particle counter sampling the charged soup of the solar wind. It hums faintly as it works, whispering statistics into the void. Beside it, the cosmic ray subsystem, always listening for high-energy guests from far-off supernovas, like a doorman for particles that travel alone very fast and with questionable social skills. There's also the magnetometer dangling at the end of a long boom to keep interference low. It tracks magnetic fields, the invisible skeleton of space, and it's been quietly mapping out the unseen for decades. And of course, there's the imaging system, which is basically two cameras, one wide angle, one narrow. You picture them now bolted to the side of this beige spacecraft, like sleepy eyes blinking open as the first planets approach. Mainstream fact, each Voyager has 11 science instruments on board, but they're not all still active. Over the years, as power dwindled, NASA's engineers had to make tough choices shutting off certain instruments to save energy for others. It's like a very long camping trip, where you start rationing flashlight batteries by year 20. One by one, the instruments dim like old lamps, but the ones still running still work. That's the miracle. Decades-old tech designed in the slide rule era, still measuring magnetic fields in the silence of interstellar space. Here's the quirky bit. Voyager's computers are less powerful than a modern calculator. Not even a smartphone calculator, more like the calculator your middle school math teacher insisted you bring that one time. They have 68 kilobytes of memory. That's not a typo. You probably used more memory reading this sentence. And yet these machines still communicate, still correct themselves, still aim their antennas with the grace of sleepy ballerinas, slowly pivoting thousands of miles with each adjustment. The commands they receive, they travel from Earth at the speed of light and take over 20 hours to arrive. You can't just hit Control-Z if something goes wrong. NASA sends instructions like letters across a windless ocean and then waits. You drift along that data stream back to Earth, where giant radio dishes on 3 continents keep listening. These are the Deep Space Network stations in California, Madrid, and Canberra. Giant white bowls pointing into the void, waiting for Voyager's next whisper. Every day they bend their ears to the sky and say, "Still there?" And usually, the answer is yes. Still there. Still working. Still measuring. Some scientists still argue whether the continued success of the Voyagers is good engineering or just sheer cosmic mercy. The probes have survived micrometeoroids' radiation, decades of cold, and the loneliness of space. Any one of 1,000 things could have silenced them, but they didn't. They just keep going. And as you float beside the spacecraft, you realize something strange. It feels alive, not sentient, not in any sci-fi sense, but persistent, determined. Like a toy someone forgot to turn off that just kept rolling. Even now, engineers back on Earth occasionally update the software. Yes, they're still programming these things, carefully with old code books and a lot of crossed fingers. They send new instructions wrapped in light, hoping the receivers still understand. The Voyagers have no GPS, no rescue, no backup batteries. Everything has to work the first time. And somehow, it usually does. You move toward the radioisotope thermoelectric generators, those small power units strapped to each Voyager like tiny nuclear backpacks. They turn the slow decay of plutonium into electricity. Not much, about 1/100th of what a hairdryer uses, but enough. Just enough. They're fading now, of course. Each year, the energy dips a little lower, and NASA plans for that. Instruments get shut off. Memory gets prioritized. But the core system's still holding on, and you can almost hear it, the heartbeat of Voyager. A soft, pulsing, ticking through empty space. Bits of data. Bits of sunlight turned into silence, turned into meaning. You settle into that rhythm. Into the slow, stubborn persistence of a spacecraft built in a decade when disco was king, and computers still had keys you had to punch. It shouldn't still be working. But here it is, and here you are. You drift now through the emptiness just ahead of Jupiter, where Voyager 1 begins to do what it was born for. Look. And Jupiter obligingly puts on a show. As you approach, the planet grows in your field of view, from a dusty circle to a seething marble of stripes and storms. It doesn't shimmer. It swirls, a gas giant with moods layered like an onion in a wind tunnel. Mainstream fact. In 1979, Voyager 1 performed its flyby of Jupiter, providing the first close-up images of the planet's atmosphere, moons, and magnetic field. The spacecraft passed just over 300,000 kilometers above the cloud tops, close enough to count the layers in those pale orange bands if clouds had countable layers. You peer at the great red spot, and for the first time, humanity really sees it as a storm. A high-pressure system, twice the size of Earth, churning for centuries. Voyager's camera captures the movement in stunning time-lapse cloud tops, sliding past one another like silent tectonic plates of gas. And you, of course, float alongside, unfazed by the 400-kilometer-per-hour winds below. Jupiter doesn't have a surface. It has layers of increasing nope. Keep falling through that gas, and you'll eventually be crushed by pressure baked by heat and liquefied by hydrogen that forgot how to behave. But Voyager, it skims the edge and keeps going. One quirky bit Voyager found that Jupiter wasn't just a gas ball, it was a radio station. The planet emits strong radio waves, amplified by its crazy powerful magnetic field. If you had the right receiver and some serious radiation shielding, you could listen to Jupiter crackle. Some describe it as a chorus of angry whales. Others say it's more like a haunted coffee machine. And speaking of fields, Jupiter's magnetosphere is enormous. If it were visible to the naked eye, it would look larger than the full moon from Earth. Voyager mapped it and found it full of radiation and charged particles, a swirling mess of electric tantrums stretching millions of kilometers. But Voyager doesn't flinch. It measures, records, sends home the data like a patient little mailman. You trail behind it, now watching as the probe pivots slightly, its narrow-angle camera focusing on something new. Not the planet, but the moons. This is where things get truly weird. Voyager discovers that Io Jupiter's volcanic moon is basically alive with lava. It sees sulfur geysers erupting 300 kilometers into space, not figuratively, literally. Imagine Mount Vesuvius, but in orbit and with more yellow. Scientists hadn't expected active volcanoes. They really hadn't expected that many volcanoes. It was like finding fireworks in a fridge. Scientists still argue whether Io's insane geologic activity is due entirely to tidal heating being tugged like taffy by Jupiter and its sibling moons, or if there are other hidden forces at play. Regardless, Voyager changed our understanding of what moons could be. Not just dead rocks, but dynamic worlds. And then there's Europa, icy quiet, too smooth for comfort. Voyager didn't get close enough to confirm it, but the images suggested something tantalizing. A cracked surface like frozen sea ice. Could there be an ocean underneath? A salty, dark sea hidden below kilometers of ice. Voyager, without saying anything, sparked decades of speculation. And future missions would circle back to Europa, with that question echoing like sonar. Could there be life beneath this frozen crust? But Voyager can't stay. It drifts past Ganymede, the largest moon in the solar system, bigger than Mercury, and records its own magnetic field, something no other moon was known to have. And then there's Callisto, distant and battered, pocked with craters, like a time-worn shield. Quiet, cold. A moon that seems to say, I've seen things. You float past them all. Tiny worlds around a planet that almost became a star, but just didn't. Jupiter is a failed sun, some say. Others say it's a success in its own category, a gravity. Well, a planetary monarch, a reminder that not all giants burn. Voyager transmits its data in a slow, steady stream back to Earth. Images, measurements, strange new questions. Scientists look at the tape printouts and try not to spill coffee on them. A lot of "wait what s" were whispered in 1979. You hang back a moment longer, watching Jupiter shrink behind you. The probe doesn't pause for photos. It doesn't slow down. There's no fuel to do either. Voyager just swings past, stealing speed from the planet's gravity slingshotting outward. One world down, several more to go. You coast now through the golden silence left in Jupiter's wake, letting its gravity hurl you outward faster and farther. And up ahead, like a beacon carved in ice and shadows, Saturn begins to rise. The ringed planet appears slowly at first, a pale yellow dot, then a fuzzy circle, then something far more strange. Because Saturn isn't just beautiful, it's weird in the most elegant way. Voyager 1, Una, arrives in late 1980. It's been coasting for over 3 years. You float just ahead of it, watching as Saturn grows into view. The rings come into focus not as a blur, not as a cartoon halo, but as a staggeringly complex system of icy fragments and gravitational ballet. Mainstream fact: Saturn's rings are mostly made of water ice ranging in size from tiny grains to school bus-sized boulders. They're flat, absurdly flat, like thinner than paper slices, spinning in a disk hundreds of thousands of kilometers wide, but only about 10 meters thick in places. You drift alongside Voyager as it tilts its camera to scan them, and what it sees isn't just beautiful, it's structured. There are gaps, divisions, wave patterns, spiral arms, bright bands, and dark lanes, each telling a quiet story of shepherd moons and gravity at play. Voyager sends back images so stunning that they almost feel fake. Rings that shimmer with the elegance of a vinyl record floating through space grooves, etched not by sound, but by resonance. And Saturn itself, sitting quietly in the middle, spinning so fast its shape is visibly squished, like a planet that's been sat on politely. And then there's the hexagon. Here's your quirky tidbit: at Saturn's North Pole, Voyager found a giant six-sided storm. a hexagonal jet stream thousands of kilometers across, perfectly geometric, spinning steadily, looking less like a weather system and more like the logo for a mysterious galactic club. And the weirdest part, scientists still aren't entirely sure why it's that shape. Some suggest wave patterns in Saturn's atmosphere. Others say it's due to differences in wind speed at various latitudes. But no one has ever recreated it quite so perfectly in a lab. So the mystery spins on six-sided and smug. As you hover beside the probe, it dips briefly into the magnetic field around Saturn, a field 20 times stronger than Earth's. Here the radiation is fierce. Charged particles scream around the planet in looping arcs. But Voyager doesn't flinch. It records, measures, transmits. And then comes the real surprise, the moons. One by one, Voyager's cameras blink open. First up, Titan. Titan is a world cloaked in orange haze, like a sepia photograph dipped in mystery. You can't see the surface. Not yet. That would take a lander years later. But even here, Voyager senses something strange in atmosphere. Not just any atmosphere, one rich in nitrogen and methane, thick enough to support weather, and perhaps lakes. You float above it now, imagining rain made of methane rivers that don't glisten, and a surface that sighs beneath a sky made for a very different kind of life. Scientists still argue whether Titan could harbor microbial life, perhaps not now, but maybe someday, or maybe long ago. It's the only moon with a thick atmosphere. That alone is enough to give it a seat at the weird moon's table. Then comes Enceladus, small and icy, barely noticed at first. Voyager just brushes past. It doesn't know yet that this tiny moon will one day become the star of future missions. That under its icy crust lies a subsurface ocean and geysers that shoot water vapor into space like cosmic tea kettles. Voyager misses those geysers, but it plants the seed. And then there are Mimas with its Death Star crater, Tethys with its great rift, Dione with its trailing wisps. Each moon quiet, cold, and utterly alien. You pause a moment to watch as Voyager 1 pulls away, having finished its tour. Unlike Voyager 2, it won't go farther into the planetary lineup. Saturn was its final flyby. It takes one last look back and then redirects upward out of the plane of the solar system, toward the stars, and back on Earth. Scientists peer at the photos and measurements and try to make sense of it all. The rings, the moons, the hexagon, the hazes and gases and gravity games. Voyager didn't just send back data. It sent puzzles. The rings alone spark endless theories. Are they ancient from Saturn's birth, or young, formed when a moon shattered? Scientists still don't know. Every new image from every new mission is a breadcrumb leading nowhere definitive. But you're not here for answers. You're here to float. So you drift behind Voyager 1, watching it vanish into the black, and you turn your gaze now toward its twin Voyager 2, still en route to places even stranger. You drift now in the long, dim corridor beyond Saturn, where the warmth of the sun thins into background noise, and Voyager 2 takes the lead. It's the only spacecraft ever to visit this next target. And frankly, even Voyager seems a little surprised to be here. Uranus. It spins into view like a pale blue billiard ball, oddly tilted, quietly rolling on its side, like it's trying to nap and orbit at the same time. Mainstream. Fact, Uranus's axial tilt is 98 degrees, which means it essentially rolls around the sun like a barrel, rather than spinning upright like the other planets. Its poles take turns facing the sun, making its seasons last 21 years each. It's the solar system's introverted gymnast, graceful, strange, and socially distant. You glide in beside Voyager 2 as it begins its lonely flyby in January of 1986. No other probe has visited since. No spacecraft has returned to check its homework. This was a one-time deal, and it's still the best view we've got. The planet itself is subtle. No great red spot, no candy-striped bands, no ringed pageantry like its neighbors. Just pale blue-green haze cloaked in clouds of methane which absorbs red light and reflects blue. It's cold. So cold. The coldest planet in the solar system, in fact, even colder than Neptune despite being closer to the sun. Like a freezer with commitment issues. You watch Voyager scan the atmosphere and the numbers come back upper layers at 224 degrees C. That's cold enough to flash freeze your hopes and dreams before you even park the rover. Here's your quirky tidbit. Uranus's magnetic field doesn't just tilt, it wobbles. It's lopsided, misaligned, and completely off-center. Imagine trying to walk through a revolving door that's spinning diagonally and on fire. That's what charged particles are dealing with out here. Voyager maps this bizarre magnetic geometry and leaves scientists blinking at the results. And you float along the field lines like spaghetti tossed by a magician. The rings are a surprise, too. Thin, dark, hard to see, but they're there. 11 narrow bands of debris, nearly invisible light. Voyager catches them mostly in silhouette backlit by the sun. These aren't the showy loops of Saturn. They're more like whispers rings that know how to keep secrets. You drift lower past the moons. Miranda comes first. Now Miranda is where the weirdness gets dialed up. It's like someone took a dozen different moons and tried to patch them together. Cliffs taller than Everest. Grooves like tectonic scars. A surface that looks like it was disassembled, scrambled, and politely reassembled without instructions. Scientists still argue whether Miranda was shattered and reformed by some ancient impact, or whether internal processes gave it this jigsaw look. Some even speculate about cryovolcanism or resurfacing via ancient tidal forces. But mostly, everyone agrees it's just deeply strange. Other moons follow Ariel Umbriel, Titania Oberon, each named like characters in a Shakespearean fever dream. Voyager's images are grainy limited, but enough to tease a new chapter of planetary science moons, with dark surfaces, old craters, and possibly subsurface oceans that no one expected. But Voyager has no time to linger. It can't brake, can't orbit. It does a flyby, and then keeps coasting, stealing speed from Uranus like a polite thief, flinging itself toward Neptune with no intention of turning back. And you feel that momentum now? That irreversible tug forward? Voyager 2 swings past Uranus and aims for the last known planet on its tour. There's a moment just before Uranus fades behind you where you pause. Not because it's beautiful, but because it's underrated. For all its awkward tilts and chilly vibes, Uranus is a scientific gift box that we barely opened. And Voyager, our single visitor, left more questions than answers. You imagine the engineers back on Earth, gathered around fuzzy images and cryptic readings, scratching their heads over a planet no one expected to steal the show. And yet somehow it did. Quietly, without rings that sparkle, without colors that pop. Just a tilted, swirling mystery wrapped in methane and magnetism. You give it one last glance, and then it disappears into the dark. Onward. You coast now into the deepest stretch. Yet your imaginary solar wind sail catching nothing at all. This far out, even the sun starts to feel like a rumor. But Voyager 2 presses forward, unwavering, aimed at a world we once barely believed was real Neptune. the last official planet on its itinerary, the last planetary postcard it would ever send home. Discovered in 1846 through math, not a telescope, Neptune has always had an air of mystery. It was predicted before it was seen. A twitch in Uranus's orbit said, something else is out there. And there it was, blue distant, dignified, and Voyager 2, the only spacecraft to visit it. Mainstream fact: in August 1989, Voyager 2 made its closest approach to Neptune, passing just 4,150 kilometers above the planet's north pole. It snapped photos, took measurements, and revealed a world that defied expectations with the quiet confidence of someone who never needed to shout. You begin to see it now. Neptune rises from the black, not with fanfare, but like a deep ocean current surfacing. Blue, but not like Earth. This is a richer blue tinted by methane, but layered with secrets we still haven't unpacked. And then there it is, the Great Dark Spot. Here's your quirky tidbit. The Great Dark Spot was a massive storm system, roughly the size of Earth, swirling in Neptune's atmosphere when Voyager flew by. Unlike Jupiter's famous spot, which has persisted for centuries, Neptune's vanished just a few years later. Scientists still argue whether these are temporary holes in the methane cloud deck or true storm systems that flicker in and out of existence like atmospheric mood swings. And the wind's insane. Neptune has the fastest winds in the solar system, over 2,100 kilometers per hour. That's faster than sound, faster than jets, faster than most people's morning commutes if they had rocket-powered shopping carts. And no one's sure how it gets the energy. The sun barely reaches this far. Something internal must be driving the dance. You ride those invisible winds, now buffeted by speed you can't feel, watching clouds whip across the planet in bright bands and broken arcs. Voyager picks up new details, rings faint and clumpy. Not as dramatic as Saturn's, but undeniably there. Named after astronomers, Adams Leverrier, they circle Neptune in half-shadow. Subtle, fragmented, like punctuation marks around a sentence we still don't fully understand. And then just behind Neptune, lit by reflected sunlight, looms Triton. Triton is weird, beautifully stubbornly weird. It orbits backwards against Neptune's rotation. That's a huge red flag in planetary behavior. It suggests Triton didn't form here. It was captured, pulled into Neptune's orbit after forming somewhere else. A rogue moon, a cosmic hitchhiker. Voyager sees geysers on its surface, actual nitrogen geysers spouting from an icy crust, leaving black streaks dozens of kilometers long. Surface temperatures hover around 235 degrees Celsius, making Triton one of the coldest places Voyager ever visited. But it's not dead. That's the strange part. It moves, breathes, possibly hides a subsurface ocean insulated beneath its frosty skin. Scientists still debate Triton's origins. Was it once part of a dwarf planet system? Did it collide with another moon before Neptune claimed it? And what keeps it active in such a frigid zone? As Voyager 2 swings past, it captures one last glance of the moon, faintly pink, oddly smooth, in places darkly cratered in others. Then it too fades behind, and with that, the planetary tour ends. You feel the shift. There are no more planets ahead, no more moons marked on the calendar, just the edge. Voyager 2 adjusts its antenna. One more time beams the data home. Everything from Jupiter to Neptune has been recorded on ancient tape, compressed, transmitted, and captured by Earth's waiting dishes. A mission planned for 4 years has stretched past a decade, and still it goes on. You float beside it now beyond the last known worlds. The temperature dips further, the starlight sharpens. The gravitational pull of the sun is still there, but weaker now. Everything is weaker, except the signal. Voyager 2 isn't done yet. It's heading toward the heliopause, and you're still along for the ride. You've passed Neptune now, and there's no going back. Not that Voyager 2 even tries. It doesn't pivot, doesn't slow. It just continues on, drifting into the dark that isn't truly empty, but feels that way. Because now, the planetary curtain has fallen. The gas giants and moons fade into memory, and what's left ahead is something both smaller and far more vast, the edge of the heliosphere. The true boundary of the sun's influence. A place so quiet it hums. But before that distant threshold comes a stretch of space that might be the loneliest in the entire solar system. You're here now floating with Voyager 1 and Voyager 2 as they cross into post-planetary limbo, a region not really mapped, not really named, just beyond. Mainstream fact: after Neptune, the Voyagers officially left the planetary region of the solar system. No more scheduled flybys. No more gravitational boosts. Just 2 spacecraft heading toward the edge of the sun's breath with only their onboard instruments and a deep space antenna handshake to remind them they're still part of anything. You float in the silence between signals, and that's when you notice it, how the light changes. The sun, once a dominant force, now looks like a bright star, barely more dazzling than the others. The solar wind thins here. The flow of charged particles slackens. The magnetic fields grow wobbly, turbulent, hard to predict. This is the termination shock, where the solar wind slows dramatically after colliding with the interstellar medium. Voyager 1 passed it in 2004. Voyager 2 in 2007. They both noticed the same thing, a shift in plasma readings, a shiver in the invisible. You ride along that ripple now, watching the data streams narrow, compress, stretch across billions of kilometers. Every byte is precious. Every signal, a tiny miracle. A quirky tidbit: it takes over 18 hours for a signal from Voyager 1 to reach Earth, one way. That's assuming the signal doesn't hit anything weird on the way, which statistically it won't. Space is mostly good at minding its own business. The probes are still sending back cosmic ray data, plasma wave readings, magnetic field directions. It's like getting postcards from a friend who moved out of town 45 years ago and only writes once a season, but still signs the bottom, "Wish you were here." And then there's the math. The astonishing patience of it. Engineers at NASA must calculate when to send commands, how long it'll take, and what might have happened in the 18-20 hours it takes for the probe to respond. It's a conversation with a delay long enough for a full night's sleep, a coffee, and a quiet existential spiral. You drift alongside the high-gain antenna, which still points home with an accuracy that's ridiculous. Imagine throwing a dart at a dime from across the United States and hitting it. That's how precise Voyager has to be to aim its signal at Earth. And it's doing this while traveling at over 17 kilometers per second, with no course correction since the 1980s. Scientists still argue whether the region between Neptune and the heliopause is part of the solar system, or simply adjacent to it. Is it still in? Or are we now just visiting from within? Definitions stretch, like solar wind, and Voyager, as always, defies classification. You check the instruments one by one. Some are sleeping now shut off to conserve power. Others tick along slowly, sipping from the fading heart of the RTG generators. Each watt is accounted for, every function balanced like a meditation, and the Earth, it's nowhere to be seen. You imagine turning the camera back just for a moment. What you'd see is what Voyager 1 did: the pale blue dot, a single pixel in a field of black hanging in a sunbeam. Carl Sagan called it home. You remember the photo, though. Voyager 1 took it after its last planetary flyby. It was a goodbye, quietly whispered through 6 billion kilometers. You float with that memory, with that distance, and with that idea that even now, with all planets behind the mission, isn't over. Voyager is still inside something. Inside the bubble of the sun's presence, the heliosphere, the final stretch before everything changes. You begin to feel it now, the press of the interstellar medium beyond the slight resistance in the particle readings. The boundary is coming. You don't see a line. There's no dotted path, just the data, just the edge. And as you approach, you glance at the instruments, still awake, still counting, still measuring the silence. No one expected them to get this far, least of all the probes themselves. You reach it slowly, almost without realizing the place where the sun ends, or at least where its influence begins to falter. There's no wall, no now leaving solar system sign, just a region where everything the sun tries to hold on to starts slipping through its fingers. This is the heliopause, mainstream fact. The heliopause is the boundary, where the solar wind, which has been radiating outward from the sun since forever, is no longer strong enough to push back the interstellar medium. It's the edge of the sun's protective bubble. Voyager 1 crossed it in 2012, Voyager 2 in 2018. And they both noticed something profound. The solar wind stopped. You float beside Voyager 1 now, as it makes that silent crossing. There's no fanfare, no fireworks, just a slow shift in plasma data. The particles coming in are different. Their direction, their composition, their energy. It's like stepping from one air current into another. Only the air is cosmic radiation, and the wind takes years to measure. Here's your quirky tidbit: scientists didn't even realize Voyager 1 had crossed the heliopause until a year after it happened. There were debates, arguments, measurements checked and rechecked. It wasn't until a sudden change in cosmic ray count and a matching drop in solar particles that they could say, yes, it's out. But here's the twist. Voyager didn't feel like it had exited anything. The sun's light still touches it. Gravity still connects it. It's still under the sun's spell. So is it really outside? Scientists still argue whether Voyager is truly in interstellar space or just interstellar-ish. You drift now in this gray zone, a threshold, not a border. Beyond this point, the magnetic fields behave differently. They twist, not like the sun's fields, but in a new orientation, suggesting you're now swimming in a different current entirely. The plasma instrument on Voyager 1 had long since stopped working by the time it crossed, but Voyager 2's was still alive, and its data painted a picture of this outer ocean denser cooler, less chaotic, like moving from rapids into a deep still lake, only colder, vastly more empty, and full of things we don't yet know how to name. The signals are fainter now. You imagine Earth as a tiny microphone, straining to hear the whisper of a traveler long since gone. The messages arrive with delay, but they still arrive, like light through thick curtains, like the echo of someone you're not quite sure is still in the room. You check the spacecraft's systems. The radioisotope thermoelectric generators still pulse with diminishing heat. Power's dropping year by year. Instruments are being shut off one by one, like a house dimming its lights as night deepens. And yet there's something reassuring about this fading persistence. The Voyagers don't panic. They don't malfunction. They just do less. A little quieter. A little slower. But still present. You watch as the high-gain antenna keeps its precise aim. Imagine this. Across billions of kilometers, the spacecraft is still pointing its 3.7-meter-wide dish, almost exactly at Earth. No GPS, no external help, just gyroscopes and instinct. And Earth still listening? At NASA's Deep Space Network, engineers still check for signals. They still send occasional commands. They still whisper across the void, "We're still here. Are you?" And the response, though delayed, still comes, "Yes, still here too." You drift a bit farther, imagining Voyager's instruments picking up interstellar plasma waves, rippling through space like the murmur of an unseen ocean. These aren't sound waves, not in the way you know them. But they carry vibrations, pressure, stories. Scientists sometimes convert these signals into audible sound-turning radio data into haunting tones. The result? A deep, fluctuating hum. A soft, galactic choir, humming in no key, with no end. And you float in that music now. Not quite in the solar system. Not quite out. Caught in a place that very few things will ever reach. A place that's more idea than location. The heliopause is not a wall. It's a fade-out. And Voyager didn't burst through it. It just kept going. Like always, you look back now, but there's nothing to see. The sun is just a dot. The planet's invisible. Home is a concept, but the journey still unfolding. Still outward. You're farther than anyone has ever been. Farther even than the concept of distance comfortably allows. And as you drift alongside the twin Voyagers, those elderly machines wrapped in foil and silence, you catch sight of something that's been bolted to their sides since launch. A golden record, mainstream fact. Each Voyager probe carries a gold-plated copper disc, a time capsule for the cosmos. A 12-inch LP record that can't be streamed, can't be paused, and has no skip button. But it plays if you happen to be an advanced civilization with a turntable, a cartridge stylus, and the basic knowledge of hydrogen spin transitions. You imagine one now, some alien archivist millions of years in the future, dusting off the probe with a tentacled arm puzzled by this odd golden disc clamped to the chassis like a galactic coaster. The instructions are etched into the record cover diagrams, showing how to play it where Earth is, how long to wait between pulses. Carl Sagan and his team designed it with the hope that even across unimaginable distances, meaning could travel with it. And what's on it? Well, that's where things get endearingly odd. There's music, of course, Bach, Beethoven, Stravinsky, Blind, Willie Johnson, and a Navajo night chant. There are greetings in 55 languages, including one from a child saying, "Hello," from the children of planet Earth. There are sounds of Earth rain thunder, a heartbeat, a kiss, a Saturn V rocket lifting off. And then there's the image archive, encoded in analog. Of course, showing Earth's people, animals, cities, food, DNA structures, Olympic sprinters, and, yes, a woman licking an ice cream cone. Because, why not? You hover beside the record, imagining it spinning softly through space, not just physically, but metaphorically. A signal of life, of curiosity, of a planet that wanted to say, we were here, and we meant well. Here's your quirky tidbit. One of the tracks is Chuck Berry's Johnny B. Good. Not exactly easy, listening for a first contact moment, but the team wanted to reflect something joyful, something loud and human. When the inclusion was debated, Sagan reportedly quipped, "There are a lot of teenagers on Earth." Scientists still argue whether the golden record will ever be found, or if it was simply an exercise in hope. The odds of alien interception are laughably small. The vastness of space isn't just big, it's cruelly empty. The Voyagers will drift for billions of years, likely, without meeting anything but dust and starlight. But that wasn't the point. The record wasn't meant to be heard. It was meant to be made. A planetary message in a bottle. Not because someone would find it, but because it felt right to send one. And maybe, just maybe someday, when Voyager is a cold, dormant artifact, drifting between stars, someone or something will find it. Not for the data, not for the images, but for the intent. The echo of curiosity, the courage of a species that dared to press record. You imagine the alien reaction, maybe confusion, maybe laughter. Maybe they skip to the whale songs and think finally a sensible language. Or maybe they hold it close, this golden disc, and realize they're not alone in wanting to connect across impossible silence. And now, you drifting beside this interstellar mixtape, realize something else. The record isn't just for aliens. It was for us too, for the people who worked on it, the children who recorded messages, the scientists who thought about Earth as a single dot, unified in message, if nothing else. You reach out to it, this quiet gold circle catching starlight it was never meant to see. You don't play it. You don't need to. It's already playing, softly, always, a record that spins forever across space, that forgets almost everything, except perhaps this. You turn your gaze now from the gold record to the Voyager itself, and you notice it's tired, not broken, not lost, but undeniably aging. It's still talking, sure, but softer, slower, like a lantern running low on oil, glowing not with urgency, but with a kind of stubborn grace. Mainstream fact, both Voyagers are powered by radioisotope thermoelectric generators, or RTGs, basically nuclear batteries. At launch, they generated around 470 watts of electrical power. Now they're down to less than half that, dimming year by year. And the demands haven't changed. Each subsystem still wants its slice of the shrinking pie. Each instrument still whispers, "Me next." But the power just isn't there. So one by one, NASA has begun turning off the lights. It's called power down sequencing, and it's as poetic as it is practical. Instruments get shut off, memory banks trimmed, heaters disconnected from non-essential parts. Every watt matters. Every decision, a quiet goodbye. You hover beside the spacecraft, now watching as the planetary radio astronomy instrument powers down. It once listened for low-frequency radio waves, cosmic background music. Now it's silent. Next, the infrared spectrometer. Then slowly, others. It's like watching an old house closing its windows for the last time. And here's your quirky tidbit. The spacecraft still runs on code that was hand-punched in the 1970s. Lines of software designed for machines with less memory than your toaster. Sometimes, when a change needs to be made, NASA engineers have to dig out printed copies of ancient flowcharts. The original programmers have long since retired. Some of them are no longer alive, but their code still runs, still guides, still listens. And now, with each year, the Voyagers grow colder. The heaters keeping their instruments warm are being turned off slowly, methodically. Parts of the spacecraft drop below freezing, yet somehow they persist. Wrapped in their foil insulation, tucked behind thermal blankets, Voyager still functions in temperatures that would stop most electronics cold. Scientists still argue whether there's any point to keeping the last few instruments on. The data trickle is small. The signal is faint. But then again, so is every whisper worth hearing. And these whispers, they come from interstellar space. So NASA keeps listening, and you keep floating. You check the schedule. The plasma wave subsystem still running. The magnetometer still measuring. The cosmic ray detector still counting. Each one given just enough power to function like candles carefully lit in a dark cathedral. There's no reboot, no software update. Everything must run perfectly with what's already on board. Which is kind of incredible when you remember that the Voyager computers don't even have an operating system as we understand it, just hard-coded instructions. Machine-level Zen. You imagine a NASA engineer today working in a sleek modern office typing commands for a spacecraft running on vacuum tube era logic. It's not just space travel. It's time travel. And when commands go out, they take almost a full day to reach the spacecraft. No instant feedback, no quick fixes. You send a message and wait. Like mailing a letter to someone sailing past Pluto. And you think, this is what patience looks like. This is what long-form science feels like. Because Voyager isn't in a rush. It's not built for drama. It's built for duration. And though its power fades, its purpose does not. Every year now, there's a new list of sacrifices. Maybe the data recorder shuts down next. Maybe we lose temperature readings. Maybe attitude thrusters are next. It's not a tragedy. It's a transition. You float a little closer and hear it, the tick-tick-tick of telemetry signals, those slow pulses of knowledge sent from the edge of the sun's kingdom. The quiet hum of a spacecraft growing dim, but not silent, not yet. You imagine what might come next? By the 2030s, power will run out completely. One day, the signal will stop. There will be no dramatic failure, no spectacular crash, just silence. A deep pause that stretches forever. Voyager will still be out there, still drifting, just no longer calling home. But even then, it won't be dead. It will simply be off-grid, a relic in motion, a silent ambassador carrying Earth's soft voice toward the stars, and you floating alongside feel something like reverence, because this isn't just machinery, it's memory, and even in the dark, it glows. You move now into the emptiest place Voyager has ever known. Beyond planets, past plasma currents, past even the sun's magnetic breath, this is interstellar space, technically speaking. But the words don't do it justice. It's not cold in the usual sense. It's not dark the way night is. It's a kind of other. A space so far removed from anything familiar that even silence feels too loud a word. And yet Voyager's still here. Mainstream fact. Both Voyager 1 and Voyager 2 have entered this realm beyond the heliopause. They are now the farthest human-made objects from Earth, moving steadily through the interstellar medium at tens of thousands of kilometers per hour, heading in different directions and still returning data, at least for now. You drift beside one watching as the sensors detect subtle changes in plasma density. tiny shifts in cosmic ray levels. Differences so faint they'd go unnoticed by almost anything else. But not Voyager. It's been trained to notice the quietest things. And scientists are watching closely, because now comes the real mystery. What's out here? There's no roadmap, no markers, just theories. The interstellar medium is made of sparse gas and dust, hydrogen, helium, the occasional stowaway atom from some ancient star's death rattle. You won't bump into much. But what's out here matters. It's the stuff between everything else, the connective tissue of galaxies, and Voyager somehow is floating through it. Here's your quirky tidbit. In 2020, Voyager 1 picked up a persistent hum, a faint, low-frequency plasma wave that scientists hadn't noticed before. It wasn't a flare, it wasn't solar, it was just there, a cosmic tone humming from deep space. Not loud, not urgent, just consistent. Like a song the galaxy plays to itself. Scientists still argue whether this hum is universal or just a local phenomenon. Is it caused by galactic winds? Is it the natural background noise of interstellar space? Or is it something else entirely, an artifact of space interacting with itself in ways we don't yet understand? You float in the hum now. No melody, but a kind of rhythm. Like the breathing of a sleeping universe. And Voyager hears it, not because it was built for this. Remember, it was designed to study the outer planets, but because it simply lasted long enough to get here. That's one of the best things about Voyager. It didn't need to be extraordinary. It just had to endure. And because it did, it became extraordinary. You ride the signal back toward Earth. It passes through the deep space network, those massive antennas on Earth that still turn, still wait, still catch whispers from the dark. There are engineers who have spent their entire careers with Voyager, who've watched it fly past worlds and into the great quiet and now supervise its last murmurs like curators of a very slow museum exhibit. You wonder what Voyager might still see. Will it pass through a bow shock, the boundary where the solar system's motion plows into the galactic medium like a boat through water? Will it encounter dust clouds more dense and magnetically tangled than expected? Or will it simply drift for thousands of years through regions no one has mapped? No one knows. There's no plan for this part, no next step, only motion. Voyager is now free-floating, no longer under the guiding influence of the sun's charged wind. It's still gravitationally bound to the galaxy, sure, but that's like saying a dandelion seed is gravitationally bound to the lawn. It will wander, not aimlessly, just openly. And maybe somewhere out there, between stars, between centuries, it will pass through something unexpected. A ripple, a wave, a whisper from another system. Or maybe not. Maybe its greatest act isn't what it finds. Maybe it's what it proves. That a little spacecraft, built by hand in a decade full of corduroy and disco, can endure long enough to outlive its designers and reach a place no one had ever truly seen. You drift beside it, still not asking for more, not demanding answers, just floating, just listening. Because here, at the edge of understanding, even silence tells you something. You drift in the endless quiet, letting Voyager pull you farther from the familiar. And at some point, you begin to wonder, where exactly is it? You turn back toward the solar system. It's not even a marble now, just a theory, a memory, a place that happened. And the Voyager probes, they're still technically in the neighborhood. But whose neighborhood exactly? Mainstream fact scientists don't agree on where the solar system ends. The planets, sure, that's easy. The heliosphere, that's another candidate. But beyond that, lies the Oort cloud, a hypothetical sphere of icy objects that might stretch up to 100,000 astronomical units from the Sun. That's over 1 trillion kilometers. Voyager 1 hasn't even left the inner edge of it. So even now, even after everything Voyager may still be in the solar system. Sort of. Scientists still argue whether Voyager is truly out or just way, way out. If you define the solar system by the Sun's gravitational reach, then Voyager won't technically leave for another 30,000 years, which feels kind of rude. It's been traveling for decades and still hasn't earned an exit stamp. But Voyager doesn't mind. It just keeps moving. It doesn't care what we call its location. It's not taking selfies or posting coordinates. It's simply doing what it was built to do: travel, measure, and speak. You hover beside it now, imagining all the layers of space it's crossed: sunlight, solar, wind, planetary, orbits, the heliosheath, and now this ambiguous sea. This is the outer solar system, if you want to be generous. The not quite interstellar, if you want to hedge your bets. Or maybe it's just the middle of nowhere, and yet it's our nowhere. Voyager isn't exploring someone else's territory. It's stretching the definition of ours. And here's your quirky tidbit. Even though Voyager 1 is the most distant human-made object, Voyager 2 is on a completely different trajectory. It's heading in another direction, entirely downward relative to the plane of the planets. If you plotted both paths on a star chart, they'd diverge like twins walking different sides of a river. This wasn't an accident. It was planned. The idea was to sample different parts of the galaxy's interstellar medium to compare magnetic fields, plasma densities, cosmic ray flows. Two identical probes decades apart, in knowledge separated only by direction. And so you follow them, both Voyager 1 to the north, Voyager 2 to the south. Each heading into silence with a different view. Each becoming a line, not a dot. That's what they are now: trajectories. Their positions don't change much day to day, not on a human scale. But their vectors are beautiful. Clean, sharp mathematical declarations of forward. They don't wander. They don't circle back. They move with intent. And what's waiting for them? Mostly nothing. No fuel to reach a destination. No propulsion to alter course. Just a path through starlight and dust between systems that may never know they passed. But, and this is important, they're not lost. Lost implies they should have been somewhere else. Voyager is exactly where it needs to be gone. Gone, but traceable. Gone, but still known. NASA tracks their trajectories, lists their last contacts, keeps time with their remaining power. There's a schedule, a plan, a long goodbye written across decades. You float back a little now and imagine their full arcs, those long parabolic escapes that began with a Saturn V thrust and ended in perpetual drift. They were built to go far. But no one really believed they'd go this far. No one thought we'd still be talking to them. And yet, here we are. Earth has changed. Governments, maps, technology, phones. But somewhere, a small spinning dish on a golden probe is still saying hello. And we are still saying hello back, even though the distance grows, even though the signal fades, even though the line between ours and out there is now philosophical. You stay a little longer beside Voyager, between what we know and what we only guess, and feel the gravity of a spacecraft that left but never disappeared. It's still in the solar system, maybe, but it's also in the story, and that might be more important. You drift now, with the golden record spinning slowly behind you, with Voyager humming faintly ahead. And you begin to wonder not what it's doing, but who it's for. Because the data, the sensors, the instruments, they were all meant for us, for scientists with charts, for engineers with coffee. But the record, that's different. That's not for us at all. Mainstream fact. Once Voyager's instruments fall silent, once the power finally fades and the antennas go dark, the probe becomes a kind of time capsule wandering endlessly through the galaxy. It carries no engines, no brakes. It will orbit the center of the Milky Way once every 225 million years. And during that journey, the golden record will continue to spin. Its grooves will not erode for billions of years. It will outlast continents, outlast the oceans, outlast us. You coast beside it now, imagining it glinting as it passes between stars. Not often, not fast, but always forward. Will anyone find it? Well, let's talk numbers. The odds are absurdly low. Space is mostly emptiness, and Voyager is small, about the size of a compact car, moving at 17 kilometers per second, without any lights beacons or pings once its power dies. It's like tossing a message in a bottle into the Pacific Ocean and hoping it bumps into a dolphin who can read vinyl. And yet, that was the plan. To send something, just in case. Not because it was likely to work, but because it might. Here's your quirky tidbit. The golden record includes a map, a literal interstellar road map made of pulsars, those rapidly rotating neutron stars that emit radio pulses with clockwork precision. Each one is unique, distinct, with lifespans in the millions of years. If an alien finds the record, they could, in theory, triangulate Earth's position in both time and space, which is either brave or wildly optimistic, or both. Scientists still argue whether this roadmap was wise. After all, we just gave the galaxy our return address. Some critics say it was naive, that if anyone does find it, they might not be friendly. Others say it was beautiful. That to reach out like this without fear is what makes us worthy of being found. You don't know the answer. But you know, this Voyager was the first to say hello, and the first to leave a calling card. And you imagine a future where someone, something picks it up. They find the probe. They decipher the instructions. They construct a stylus. They spin the disk. They listen to Bach, to greetings in 55 human tongues, to the sound of a heartbeat, a baby crying, laughter, and maybe, just maybe, they wonder who we were. Not our politics, not our industries, not even our technologies, but our intent. Voyager's record isn't about what Earth is. It's about what it hoped to be. And even if it's never found the act of sending, it was enough. Because every message says more about the sender than the receiver. You imagine Carl Sagan, now quiet, smiling, speaking softly into the cosmos, saying things like, "For small creatures, such as we, the vastness is bearable only through love." And you believe him, because he helped send this tiny proof that we were here, that we looked outward, that we cared what was out there. You drift a little farther now. The record gleams gold. The spacecraft whispers home. Earth is so far behind you, it's no longer a point, just a remembered place. And you realize this isn't just a mission, it's a story. A long, patient story we told the stars, in hopes they'd listen. You coast alongside Voyager now, far from everything, and you start to picture a strange scene, one that's still happening even now. Back on Earth, in quiet control rooms and fluorescent lit offices, a small team of people is still talking to it, still sending signals, still listening. Mainstream fact. NASA maintains contact with the Voyager spacecraft using the Deep Space Network, a global array of radio antennas located in California, Spain, and Australia. These dishes can receive signals billions of kilometers away, weaker than a wristwatch battery scattered over time and distance, but still there. Every day, engineers wake up, go to work, and try to contact something built before the internet, before GPS, before most of their current coworkers were born. You drift with that idea, now Voyager, as a ghost ship sailing further every second while Earth still whispers, "Can you hear me?" into the dark. Here's your quirky tidbit. The Voyager team includes people who have been working on the mission since the 1970s. Some have spent their entire careers with these probes. For them, this isn't just science. It's a relationship, a long-distance one, where the other person is always leaving and never calls first. And they still send commands slowly, carefully, like letters through molasses. Sometimes they update the software. Sometimes they recalibrate a sensor. Sometimes they just say, "Stay alive." There's a certain poetry to that. Imagine typing a few lines of code in Pasadena, knowing it will travel 20 billion kilometers, bounce off a spinning metal disc, and make a 46-year-old spacecraft pivot its antenna 1 degree to the left. That's not just engineering. That's faith. Scientists still argue whether it's worth it. The signal is weak. The data is sparse. The power's almost gone. But every byte that comes back is a miracle of persistence, a whisper from the very edge of possibility. And so they listen. The Deep Space Network rotates its dishes to track the signal. Massive steel structures slowly turning night and day pointed at a spacecraft no larger than a subcompact car, sailing in a straight line through nowhere. You float by one of those dishes now, somewhere in the Australian outback, quiet except for the hum of equipment and the soft rustle of desert wind. The dish tips slightly. A technician makes a note. A faint ping arrives. A heartbeat. Still here. Still working. Still Voyager. You drift back to the spacecraft itself. Its power reserves are nearly gone. The instruments are shutting down one after another. But the telecommunications system, the antenna, the signal processor, the transmitter is still on. And it will be the last thing to go. In the end, when all else is silent, Voyager will still be trying to talk. That's the final grace of it. Not the science, not the trajectory, not even the golden record. It's the conversation, a signal, a reply, a moment of contact between what is and what was. You imagine the last ping. It might come in a few years. Or maybe a little longer if everything holds. It'll be faint, compressed. Maybe just a burst of static that someone will run through algorithms again and again to extract that one final breath of data. And then nothing. No alarm. No warning. Just silence. But not the kind that means gone. More like the kind that means arrived. You float in that silence now, feeling how full it is, not empty. Full of effort, of distance, of love disguised as engineering. Because somewhere right now, someone is staring at a monitor, waiting, hoping, pressing a button, just to see if a message comes back. It's not for the science anymore. It's for the story. And stories like spacecraft can keep going long after the voice goes quiet. You drift now beside the Voyager probes as they enter the final quietest part of their journey. No more planets. No more missions. No more course corrections. Just movement, soft, steady, unending. They are still sending data, but just barely. The light that once poured from their nuclear hearts is fading watt by patient watt. Instruments are shutting off like windows at dusk. The heater's long lifelines to delicate parts have been switched off. Some components are now colder than Pluto's shadows. And still, they drift. Mainstream fact, sometime between 2025 and 2030, both Voyager spacecraft will fall permanently silent. Not because of a single failure, but because they will simply run out of power. They will still exist, still move, still carry their golden records, but they will no longer speak. You float beside Voyager 1, now watching its antenna make one final calibration. A twitch, a pulse, a signal so faint it might as well be a sigh. Then the transmitter flickers, and with that, Earth's most distant voice begins to dim. You might imagine this as an ending, but it isn't. The data stops, yes, but Voyager continues. Its trajectory is unchanged, its motion eternal by human standards. With no atmosphere to drag it, no gravity to pull it back, it becomes a message in motion, a drifting dot in the galaxy. And here's your quirky tidbit. Long after Voyager stops transmitting, long after its power is gone, it will still be intact. Radiation and micrometeoroids may scratch its surface, but in the cold of interstellar space, decay is slow. Some estimate the probe could survive for billions of years longer than Earth's continents, longer than Earth's oceans, longer perhaps than Earth. Scientists still argue whether the Voyager's final contribution will be scientific or symbolic. But maybe it's both. Because even when silent, they'll still be out there, still proving it was possible to leave, to endure, to keep going. You drift beside Voyager 2, now watching its last systems flicker. Maybe the magnetometer lingers a little longer. Maybe the cosmic ray detector gets one last reading. Then the lights go out one by one, and nothing breaks. There is no crash, no flame, no sound. Just a spacecraft slowly fading into the dark like a candle going out in a cathedral where the walls were never built. You wonder what happens to a mission when no one hears from it anymore. Does it still count? Does it still mean something? Yes, because the journey continues even without a narrator. Voyager is now legacy in motion, not exploring new places, but becoming one. It will pass other stars. Not soon, maybe not for 40,000 years, when it drifts near a red dwarf named Gliese 445. Not close enough to land, just close enough to say I was here, and still farther into galactic drift, into the long tide of stars and dust and time. And maybe someday, in some quiet part of the universe, something with eyes or sensors or questions will find it. Not because it was looking, but because it was listening, and it will hear Earth's faint echo. And now, you're still floating here, beside that echo, watching as the signal fades, watching as Voyager becomes what it always was meant to be, not just a machine, but a gesture, a hand extended into forever. And the best part, it worked. We reached farther than we thought we could. We spoke. And for a while, the sky answered. You look back toward home now, just a whisper behind you. You look forward into the stars now, just possibilities ahead. And Voyager, it just keeps going, forever. You're drifting still farther now than even memory can follow, held in the gentle pull of a story that didn't end, it just became quieter. The stars ahead of you no longer twinkle. They wait. And Voyager, silent now, is still moving among them. Slowly, calmly, like a thought that never stopped. You let go of the spacecraft. It doesn't notice. It doesn't need to. Its path is set. Its voice has become part of the background. But its meaning lingers, like warmth in a room after the fire has gone out. The message whispered across time and silence still rings out that we tried, that we reached, that we sent our music and math and laughter and languages into the dark not for answers, but because the dark was there, and now it holds them. You breathe slowly, deeply, matching the rhythm of the stars. The stillness doesn't press, it welcomes. There is no urgency, no sound. Only the deep quiet knowing that something human once passed this way, and still does. So rest easy now. You've traveled far. There are no signals left to hear tonight. No more course changes. The last of the instruments are quiet, and the space around you is peaceful, as it should be. Let the echo of Voyager follow you into sleep. Let the silence become a lullaby. Let the motion remind you that you're still part of something vast and kind. Close your eyes. The stars are listening, and Voyager, still drifting, still shining, forever outward. Sweet dreams.